Today I am going to explain the bistable configuration of 555 timer IC. As the name suggests, in bistable mode, the output of the 555 IC will have two stable states. First one is low and other one is high. Now in the bistable mode of the 555, the output pin is controlled by two inputs. The first one is connected to the reset pin and other one is connected to the trigger pin. And the output remains in its current state until the next input causes it to change. Now here two push buttons are acting as input. So when you press the top push button, which is connected to the trigger pin, the output pin goes high and the load, which is the LED here, turns on, and it remains in the on condition until we press the bottom push button, which is connected to the reset pin, to turn it off. And if you haven't watched my previous video in which I explained the detailed working of the 555 IC and the monostable mode, I would recommend you to watch this video first to get a more clear idea about the 555 IC. Now let's see what happens inside the 555 in the bistable mode. So this is the internal circuitry of the 555 IC, and there is a comparator number 1 whose negative input is directly connected to the trigger pin and the positive input is connected to the 1/3 of VCC through a voltage divider across the VCC and the ground. So when the voltage at the negative input is greater than that on the positive input, the comparator outputs low voltage. And if you take the reverse of it, when the voltage at the negative input is less than the voltage at the positive input, the comparator outputs high voltage. That's why when you press the push button connected to the trigger pin, the voltage on the trigger pin becomes low, which is less than 1/3 of VCC, and that's why the comparator outputs high. Now coming on to the bottom push button, which is connected to the reset pin. So what happens when you press it? So after pressing the push button, the RS flip-flop gets reset, and because of this, the output pin goes low. Now let's have a look at the circuit connection for bistable mode. So on this IC, if you see, there is a small semicircle cut here at the top. So the numbering starts from the left side of this cut. The top pin is the first pin, which is the ground. Second one is the trigger pin, which is connected to the push button through a pull-up resistor, right? The third pin is the output pin, which is connected to the LED, this LED through a resistor. And the bottommost pin is the reset pin, which is connected to, again, the push button. This fifth pin is a VCC, which is connected to the positive rail of the breadboard. The sixth pin is a discharge pin, which is I am leaving as unconnected because it is a basic circuit. But if you want to build more complex circuit, including more number of ICs, devices or microcontrollers, you may require to connect this pin to something else. And the seventh pin is the threshold pin, which is connected to the ground. And the last pin, which is pin number 8, it is a control pin. So generally it is connected to the ground using this capacitor of a small value. So this is the 0.1 microfarad capacitor. You may also use lower value than this. Now I have connected the battery on the power rails of the breadboard, and if you press the push button connected to the trigger pin, the output pin goes high and the LED turns on, and it will remain in the on state until I press this push button connected to the reset pin, right, to cause the LED turn off. Again, if you press the push button, the LED turns on. Again, press the reset push button, the LED turns off. So this is how this bistable mode works. So let me know in the comment section what project will you use this bistable mode for. And if you enjoyed this video, don't forget to subscribe to my channel and share this video. And thanks for watching.